National here is Galeão, and here is the Pier Mauá, which the museum is placed now. I invite you to go to Rio and take some caipirinha and visit the museum. It's very, very good. The museum itself, it's part of a plan for changing those areas. So not only the museum of tomorrow, but this building here, that building here is part of another retrofitting. And we built a floating slab that we call, which is 20 centimeter thin floating slab here to connect and to cover both buildings. And as I told you, it's part of a huge change of Rio. And now I'm going to show you the museum itself. There's a picture of the main design, the main designer, which part of time is my father, Julio Timerman. And also here's the Calatrava. He's the main architect of this project. So the museum itself is a low-rise building, but is very extended. It's about 1,000 feet long and 60 feet high. So it's very high, low-rise building. And there is a video about the project itself that I'm going to show you. Mm-hmm. Yeah. Well, it's beautiful, but we have to realize that project, because it has a lot of cubes. So that's the virtual model that is from the architecture design. So we have to build it, to do it. That's the main problem of this project. So we are talking about every part of this project is concrete. We could not use like other materials than apparent concrete and steel, and all white in the shore of Brazil. So it's very difficult. We have to think about it and to construct it itself. So there's some models that we are showing, and we are going to compare after construction of the building itself. So the models itself, but the first part is the foundation. The museum itself is going to be placed, or is placed right now, in a pier. So we have to evaluate this pier, if it's good or no, to build the building. So the first part was to evaluate this pier that was constructed in 1950. So it wasn't good. We have a lot of foundation collapsed. So the first part of our job is to do another foundation. So the building itself is completely separated, splitted from the pier original design. So that's one of the key of our design. So the building itself, on this representative photo, it's about 2 or 3 layers, pavements. The lower one here, which is the structural, and the first part of the layer, which is the main entrance, and the second part of the representation. So it's like, as I said to you, is a low-rise building, and here's a representative for loads, and the structural upper part is fixed to 4 points of the concrete structure. So it's very singular when it goes to the structure design. Okay. The materials itself, we use for concrete, you use the C30 and the C50, which is about 4 to 6 KSI, 7 KSI, and we use like normal rebars with 72 to 87 KSI, and of course pre-stressed rebar also. The plans itself, that's the lower part of the museum, and we are going going in the upper parts, which is the main exposure area, divided with a lot of different loads for the museum. And we have a technical layer between the upper part and the main entrance. And of course, the second part, or the second layer, which is the museum is placed on. So that's the best part, the structure design. We are talking about a building with 1,000 feet. And to get into a model, a design model, a structural design model, is very difficult. We took like 4 to 5 months just to take place the structural design, because we have a lot of dots, nodes, and we have to represent the real deformation, the real materials that we are going to build this building. So we took like 4 to 5 months just to take place this structural design. As you see, this is the model 3D. So we took from the architecture, we did some implementation on 3D model, and of course to do the limit finite model to get some design about this building. And we have, because of the limitation of the program, we have to split in 4 parts, where we place some expansion joints on these parts to take place to build this building and to calculate this building, to dimension it. And this is the post-processor, and here's what we call this is the model itself, and therefore we took a post-processor to see what was the rebars that was necessary to place this museum itself, this building. So Also, we have to take some efforts from the upper part, the metallic. So we have some pots, metallic pots from the upper part that's going to connect to the concrete structure. So we have to think about everything and get place and take into everything and think about this and implementing the structural design. It's very difficult to do it. And when it's done, well, it's great. But we have to take time to do it. So we have some space, some special elements in this project that I'm going to show you in the next slides. Of course, because of the format of the building, we have to use in 2012 some BIM models. We are talking about 10 years from now. So for special projects, we are talking about BIM right now in structural design or design itself. We are talking about 10 years from now, so we have to use it. It's still use it, but we have to use it to build this design, this building 10 years. So about the design itself, we implement on the BIM model and go to the production site to produce these formats, those elements, okay? And this is the construction itself. Well, about some numbers of the work, we are talking about 26,000 of framework square meters in about 28,000 square meters of special framework, curved, of course, and square, and that's it. Well, as I told you, we have to use some BIM model to do the framework, not only the framework, but some elements also, because it was very special, as you see. So every part of this project has to have a coordinate to build it. So it's very, very special. And of course, the key of this project is to not only elaborate the design itself, but we have to participate from the work. So we went to the work like one per week. We have to be there. It has to be a networking between the structural design, the architecture. Everybody has to work together to implement these jobs. It's very good. So there's some parts of the special elements, which is the technical galley here. Here is the slab with like 20 to 30 feet cantilevers with just anchorage point. And there's another one here which is like a pinion pressed. It's called. It's very singular because it's all traction. There's no point of lower part of compression. I'm going to show you. About the design itself, we produced like 500 blueprints for this project. So it's a lot of work to do it. And as I say, we have every part of this design, we have to put some coordinates to implement on the work. It's crazy, but to construct this project, we have to do it right, okay? So that's the type of detailing that we did on the past and we implement now. It's done there. So I'm going to show you some special parts. And this is, as I told you, the main slab of the interest of the building. So we have to pre-stress it. And not only this, but as we are talking about a slab here with a span of 100 feet long. So we have to pre-stress it. That's the only way to build it up. Okay. And of course, a lot of connection between not only structural but architecture and hydraulical and electrical. So a lot of things to do. That's the pre-stresses. That's one of the pre-stressed slabs that I'm showing to you. And the implementation of the lower part, which is the cafe. From this cafe, you can see the Guanabara Bay. So it's very beautiful right now, but for design, it's terrible. But it's good. It's good now. Well, and of course, not only the building itself, it has a water. It's like, well, the Calatrava think about that the museum should float from the water. So it's implemented like a slab with water for all the parts here. So we have to build this slab, which is it's like a 10,000 square meter slab divided by expansion joints, each 100 feet long. So we have to think about it, to construct it, and to maintain and to give life. Okay. There is the lower part of the design is below the sea level, so we have to calculate and mention it for water pressure also, and to maintain it to get a waterproof materials and use concrete, special concrete for the sustainability and the durability of this concrete. That's also some parts. So this is the part that we use for the walls of this part, the lower part. We use some pile beams joined together. That's the first floor that we are looking for, and that is a construction picture about it. That's some beam parts and implemented on the field. That's the best part, huh? Well, that the technical floor between the first and the second one being constructed, and that's the slab here on a beam model, and it doesn't connect anything to the first floor, just to the upper part. So all the piles has traction on it. It's like no compression, just traction connected to the upper part of this building. Okay, and the second floor, which is the lowest one because it has all the exposure parts of the museum. So it has very high loads of the museum and how it was built in Rio. So that's some parts of the museum, some pictures that we are showing to you. And the technical galley, which connects everything from the museum, electrical, hydraulic. It's about well, we are talking about 70 feet span from these slabs, these elements. So we have to calculate this to implement and to be built on the field, in the field. That's the main part. The first part of the museum that I show you previews on the model itself, the architectural model that is being built here, which is the slab with feet of cantilever and no points connected to the lower part of the building. So everything here is concrete, and this part here is pre-stressed. And we have to think about the deformation during the time. So it's we have to implement everything and control it. That's the main part of this job here. So everything that I'm showing to you is concrete, pyramid concrete, white, okay? That's the pigeon breast that I told you, which is the technical galley. And that's the implementation of this element here on the museum. That's another part of the museum that we show here to you. And some technical galley and the exposure and the corridors of the museum. So it's very nice. And the back of the museum, which here is the Guanabara Bay. And here is some implementation of this job with apparent concrete. So that's it. And that's the main pillar of this building here. We have just 4 pillars itself, and every wall, it's a structural wall throughout all the building. So we have to use the parts of the museum to be a structural element. That's the pile here, very thin pile, but it has a strong load on that. That's also another pile here. And that's the auditorium. Oh, sorry about it. That's the auditorium that we built on the front part of the museum. And also, for the exposure, we have to think, as I told you, about the loads. So each part of this weighs like 1 ton. So we have to think in all parts of the museum to be placed and to be built after. So also there is a structural steel designed for the upper part of the museum. As the video that I show you, it moves during the day, following the sun to get the solar panel, the optimal charge from the sun. So not only the static loads, but the dynamic loads of this covering, we have to think about it and to implement on the model, okay? So that's the final part of the museum. Here is a cantilever of 200 feet long cantilever of steel. And here's the front part of the museum and how was constructed on the field. Here's there is some front view from the museum being constructed, and almost there, the steel covering, the steel upper part is getting placed, and now the museum itself almost done, almost on the day of the opening. And also, as I told you, we have to think about the instrumentation to the deformation of the structural design, the structural concrete during the opening or during the loads. So we try to get some info from the design, the structural design, and to get to follow it during all the works. So that's it. It's still there. It's good to visit, and thank God is one of the place to go in Brazil now. About numbers, a little bit of numbers here. We use like 22,000 of concrete, 3 million tons of rebars and about 120,000 of pre-stressed rebars. Okay, that's the day of the opening of the museum, and that's it, folks. Thank you all for your time.